All right, let's talk about DNS. For a lot of us, it can feel like a total black box, right? Well, today we're going to pry that box wide open. We're putting together a complete toolkit to give you total visibility into your DNS on AWS, focusing on the incredible monitoring tools inside Amazon Route 53. Let's dive in.
You've been there. I know you have. An application goes down, the alerts start firing, and everyone's scrambling. Is it the code? The database? The network? Or could it be DNS? That invisible layer that, when it breaks, takes everything else down with it. For too many teams, it's a complete mystery. We're going to fix that today.
So, here's our game plan. We're going to start with the why you even need a plan in the first place. Then we'll get into the nitty-gritty with the two key types of logs. After that, we'll get proactive with health and performance checks, we'll lock things down with security tools, and then finally, we'll wrap it all up with your complete DNS monitoring toolkit.
Okay, first things first. Before we click a single button or look at a single log, we need a plan. You know, great monitoring isn't about just sucking up every piece of data you can find. It's about being smart and asking the right questions before things go sideways. And these, right here, are the core questions. This is the 6-step framework from AWS, and honestly, it's the foundation for any solid monitoring strategy. It makes you think about the what, the where, the how often, and with which tools. But you know what's really crucial? The last two. Who's going to do the work, and who gets that 3 a.m. page when things break? Answering these questions up front means every bit of data you collect actually has a purpose. All right, tool number 1 in our kit, logging. Seriously, think of this as the flight data recorder for your DNS. It captures every single query. This is how we stop guessing and start knowing what's actually going on. Now, there's a really important split here. Let's break it down. Public DNS query logging. That's for watching the outside world looking in. It's all the traffic from the internet trying to get to your public websites. Then you've got resolver query logging. That's for everything happening inside your house. Queries coming from your VPCs and your on-premise servers. You absolutely need both to get the full story. So when you look at these public logs, you get some amazing clues. You can see the exact domain someone asked for, the type of record, and, this is a big one, the response code. So for example, if you suddenly see a huge spike in NX domain responses, that could mean a typo in a big marketing email you just sent out, or, maybe something a little more sinister. It's your first breadcrumb. Now, with resolver logs, things get even more flexible. See, public logs go right to CloudWatch, which is great. But here, you've got options. You can send them to CloudWatch for live monitoring and alarms, sure. Or you can archive them super cheap in an S3 bucket for long-term compliance. Or, and this is really powerful, stream them through Kinesis to do some heavy-duty, real-time analytics. Now that's what I call flexibility. And this is where it becomes a superpower. Resolver logs are context-aware. They don't just tell you what was asked, they tell you who asked. Right down to the VPC, the source IP, and even the specific EC2 instance ID. I mean, come on. And check out that last field. You can see if your DNS firewall actually stepped in and blocked the request. For debugging what's going on inside your network, this is pure gold. Okay, so logging is awesome for looking back and figuring out what happened. But what if we could prevent problems from even starting? Let's add the next tool to our kit. Proactive monitoring. Think of this as giving your applications a regular physical checkup. Meet your new best friends, Route 53 Health Checks. These are your automated frontline defenders. They're constantly checking your servers from all over the world, making sure they're not just up, but responding correctly. And if they spot a problem, they can take action automatically. In the world of health checks, this is the number you want to see. A health check status of 1 gets sent to CloudWatch, and it basically means everything's good. All systems are go. And then there's this number, 0. A status of 0 means something's wrong. The endpoint is unhealthy. But here's the magic. Route 53 can see that 0 and automatically stop sending traffic to that failing server, routing it to a healthy one instead. This can literally prevent an outage before a single customer ever notices. How cool is that? Now, for your internal DNS, health is also about performance. And that's where resolver endpoint capacity comes in. This isn't just a simple, is it up or down metric. It's about whether your resolver is getting overwhelmed by the sheer volume of queries from inside your VPCs. Think of it as a bottleneck detector for your internal DNS. So this metric has 3 states. 0 means you're okay. A 1 means, uh-oh, you're over 50% capacity. That's a warning. And a 2, Well, that's critical. You've passed 75%. The takeaway here is super simple. If you start seeing ones or twos pop up in your metrics, that's a crystal clear signal that you probably need to add more network interfaces to that endpoint to handle the load.
Okay, we've covered visibility and health. Now let's talk about locking things down. The next tools in our kit are all about protecting your DNS from bad actors and keeping a perfect, unchangeable record of every single change that happens. Let me introduce you to the security guard for your DNS, the Resolver DNS Firewall. It's simple but so effective. You can give it lists of known bad domains, and it will just block any traffic from inside your VPC that tries to go to those sites. This is your #1 defense against things like malware calling home or data being snuck out of your network. And it gets better because it plugs right into this amazing automated workflow. So when the firewall blocks a query, it doesn't just drop it on the floor. No way. It sends out an event to Amazon Event Bridge. And from there, the sky's the limit. You can trigger a Lambda function to do something, or like you see here, send an alert directly to your security team's Slack channel. That is real-time automated threat response. But what about changes to your DNS setup itself? Who has the keys to the kingdom? That's where AWS CloudTrail comes in. It is the definitive record keeper. Every single API call, whether it came from the web console, the command line, an SDK, it's all logged, giving you a complete tamper-proof audit trail. So picture this. It's the moment we all dread. Your main website's DNS zone just vanishes. Total panic, right? Well, with CloudTrail, you just calmly go to your logs and search for this one event, delete hosted zone. And boom, right there, it will tell you exactly which user did it, from what IP address, and at precisely what time. A potential crisis just became a 5-minute investigation. Whew, we have covered a ton of ground. We've gone through logging, health checks, firewalls, auditing, the works. So let's pull all these pieces together and give you a quick summary of the complete toolkit you now have ready to go. And here it is, your whole toolkit on one slide. Think of this as your cheat sheet. For visibility into every request, you've got query logs. To stop outages before they start, you've got health checks. To block threats at the door, you've got the DNS firewall. And to track every single change, you've got CloudTrail. Put them all together, and you have comprehensive command and control over your DNS. You know, we started this whole conversation with DNS being a blind spot, a black box. Well, now you have a complete toolkit to flip on the lights. So the real question isn't about what these tools can do anymore. It's about what you're going to do with them. What weird inefficiencies, what lurking security risks, or what hidden performance bottlenecks are you going to uncover now that you can finally see everything that's happening inside your DNS?